All right, my name is Tomo. I'll be talking about my final project at ZK University. It's called Continuum. It's a background checker using zero-knowledge proof. First, I'm sharing about the problem that I want to solve. We've seen difficulty improving your background when you are working with your pseudonymous account. For example, the traditional background checks can be done without revealing your real identity. And not all data is required for the background check, but currently they are shared to all the data is shared. Lastly, employees don't have a control of their personal data, so it makes really hard to work pseudonymously because you don't know who knows your personal information. Here's my solution. We can minimize how much you have to expose your personal data using zero-knowledge proof. And how it works. In this flow, a company asks you for the background check, and you will do so by using the third-party background check service. And this data is owned by you, and you can selectively share data in a way the company can't identify you. For example, you can share that you worked at a big tech company without sharing your real name or any reference. And zero-knowledge proof will provide such that your pseudonymous account is authorized by the third party and also the requested data is legit. So I worked on proof of concept product using GitHub account. User can selectively reveal their GitHub profile data without revealing their account. So in this screen, you see that this account has more than 100 followers and account is active for more than 6 years and receiving more than 100 stars. You can reveal this data to share to others, and then afterward you can also mint your NFT to make it visible on chain. This is the overview of the flow. In the first step, you will get authorized and get data from GitHub, and this data is stored locally and will not be shared to anywhere. And when you decide to reveal the data, you will insert your data to Merkle tree. And this Merkle tree will have the commitment hash. And this commitment hash is generated from the signature of user data and which data to reveal. And in the last step, you can generate the zero-knowledge proof from the Merkle proof, and you can submit this on the blockchain. And in this proof of concept, we have a contract on Harmony, and there's a verifier contract that you can verify this proof. And once it's verified, you can mint your NFT. All right, so it's available on Harmony testnet, and here's a link. And I'm going to show the demo next. Okay, I'm going to show the demo. So this is a landing page. I'm going to connect my wallet. Right. Now, the next thing you will do is connect to your GitHub account. All right, so I see this, authorize being redirected. And notice that this data here is only stored locally, and this will be used for generating your proof. And based on my GitHub profile, I have more than 100 followers. I have an account that has been there for more than 6 years, and I have stars received for over 100. And they are not being revealed right now. So I'm going to review the data that I have more than 100 followers. So I would say that my account is legit. It's not the account that I created like a few days ago. Okay, so now the data is revealed and the commitment hash you'll see and says yes. And I'm going to mint an NFT here. So you can see the progress here, currently collecting commitments from the Markov proof. And then next step is generating a proof using ZK snarks. And this may take a while, and it's happening on the browser right now. Roughly, it takes about 10 seconds, but it may take more depending on the situation. Okay, so now it's verified, not verified. The proof is generated. Now we're going to the step where we verify this on the smart contract. Okay, there we go. All right, so this has been posted on the Harmonies test network, and we can see the transaction has been submitted. Okay, there we go. All right, so this has been submitted, and so my proof is verified properly, and NFT has been minted to my account. Okay, so that's it for the demo.